Hello everybody, my name is Askar Khan, your math coach on Wisdom Outlined Coaching. Welcome to the channel. In this lesson, we will understand the laws of exponents for real numbers. So let's dive into the lesson and understand what these laws are. You have learned what 2 to the power 2 means. What does it mean? It means 2 times 2, which is of course 4. 2 times 2. Okay. What does 2 to the power 3 means? It means 2 times 2 times 2, which is 8. Now, think carefully. What does 2 to the power 2 times 2 to the power 3 will be equal to? Can you guess? 2 to the power 2, can I write it as 2 times 2? Yes. And 2 to the power 3, can I write it as 2 times 2 times 2, which is nothing but 2 to the power, how much? 1, 2, 3, 4, 5. So it is 2 to the power 5. Do you observe something? 2 to the power 3 times 2 to the power 2 is equal to 2 to the power 3 plus 2, which is equal to 2 to the power 5. Am I right? So from this, we can deduce one law of indices, and that is the first law, which says that a to the power m times a to the power n is equal to a to the power m plus n. Now this a is called the base, and m and n are called the exponents. So we can write it here, a to the power m. This is called exponent, and a is called the base. So what do we understand? When the bases are same and when they are multiplied, the powers get added. For example now. Example, can you tell me, based upon the law, 17 to the power 2 times 17 to the power 5 will be equal to how much? It's going to be 17 to the power 2 plus 5, which is nothing but 17 to the power 7. So do you understand how we apply the law now? Let's move on further. Let's take the second law and try to understand. Suppose 2 to the power 3, we already know what it is, 2 times 2 times 2. And if I divide it by 2 to the power 2, what is it going to be? It's 2 times 2. So now observe, can I cancel these 2's? What am I left with? Only 2. And when there's no power written, what is the power? It is understood to be 1. So do you observe now? Can I write the same law? 2 to the power 3 divided by 2 to the power 2 is nothing but 2 to the power 3 minus 2, which is equal to 2 to the power 1. Do you observe? So from this, we can come up with the second law of indices, which says that a to the power m divided by a to the power n is equal to what? A to the power m minus n. When the bases are same and when they are divided, what do you do with the powers? You subtract the powers. This is the second law of indices. Let's try an example. Let's come up with an example now. Can you figure out what will be 23 to the power 10 divided by 23 to the power 7. The questions that you must ask yourself before solving is, are the bases same? Yes. And these bases, are they divided? Yes. And so when the bases are same and when they are divided, what do you do with the powers? You subtract them. So it's 23 to the power 10 minus 7, which is 23 to the power 3. So you know how to apply the law now. Similarly, you can deduce the third law of indices, which is a to the power m. The whole thing raised to the power n is a to the power m times n. Let's understand this law again. 2 to the power 2, the whole thing is raised to the power 3. What does it mean? It means that 2 to the power 2 repeats itself 3 times. That's what it means. In other words, it's 2 to the power 2 times 2 to the power 2 times 2 to the power 2. And we know what 2 to the power 2 is. It's 2 times 2 times, again, this is 2 times 2, and again, this is 2 times 2. Can you tell me how much will this be now? 1, 2, 3, 4, 5, 6. So can I write this as 2 to the power 6? Which is same as 2 to the power 2 times 3. Do you observe how the law is working over here? So we have a to the power m. The whole thing raised to the power n is equal to a to the power m times n. That is the application of the third law. Let's try an example. Can you tell what is the answer of this? 5 to the power 2, the whole thing to the power 7. It is going to be 5 to the power 2 times 7, which is 5 to the power 14. Very good. Excellent. So we have the 3 laws of indices so far, and they are a to the power m times a to the power n is what? A to the power m plus n. And what's the second one? A to the power m divided by a to the power n is a to the power m minus n. What's the third one? A to the power m, the whole thing raised to the power n is a to the power m times n. Now, there's another one, fourth, which is pretty obvious. A to the power m times b to the power m, which is now, observe over here, the bases are different, but the powers are same. So what do? We can multiply the bases together and write them as a times b, the whole thing to the power m. For example, for this, 3 to the power 2 times 2 to the power 2 can be written as 3 times 2 to the power 2, which is of course 3 times 2 is 6 and 6 to the power 2. We have another law over here. Nth root of a is equal to a to the power 1 over n. For example, cube root of 2 can be written as an exponent 2 to the power 1 over 3. Another example, fifth root of 4 can be written as 4 to the power 1 over 5. So we can apply the law of exponent in this case too. And look at this now. nth root of a to the power m. How can I write this? It is a to the power m, the whole thing to the power 1 over n. And we already know what is the law of a to the power m, the whole thing to the power n. Can I write this as a to the power m times 1 over n, which is nothing but a to the power m over n. Example 2 to the power 3 over 2. Can I write this as 2 to the power 3, the whole thing to the power 1 over 2? And when the exponent is half, it is nothing but square root. So this is square root of 2 to the power 3. So look how we change this into the square root form, and how the square root form can be changed into the exponent form. Let's try this example. Simplify 2 to the power 2 over 3 times 2 to the power 1 over 3. If you observe, are the bases same and are they multiplied? So when the bases are same and if they are multiplied, what is the law? Remember the law, a to the power m times a to the power n is a to the power m plus n. So we can apply this. So it becomes 2 to the power 2 over 3 plus 1 over 3. And we have learned how to add fractions. Since the denominators are same, we can add the numerators. So it's going to be 2 to the power 2 plus 1, 3 over 3, and which is 2 to the power 1, which is same as 2. So this is the simplification of this. Simplify this. 3 to the power 1 over 5, the whole thing to the power 4. What is the law that comes to your mind? Remember the law, a to the power m, the whole thing to the power n is what? A to the power m times n. So if we apply this law, this is going to be 3 to the power 1 over 5 times 4, which is nothing but 3 to the power 4 over 5. So this is the simplification of this. Let's apply the law. What is the law that comes to your mind for this? 7 to the power 1 over 5 over 7 to the power 1 over 3. What is the law of a to the power m divided by a to the power n? It is a to the power m minus n. So can I apply this law over here? So it's going to become 7 to the power 1 over 5 minus 1 over 3. And in our lower grades, we have learned how to subtract two fractions. 1 over 5 minus 1 over 3. Are the denominators same? No. So I have to make the denominators same. How do I do that? I can multiply the first fraction with 3 and the second fraction with 5. So what do I get? Now the fraction is 3 over 15 minus 5 over 15, and 3 minus 5 is negative 2 over 15. So now I can use this over here, which is 7 to the power negative 2 over 15. That is the answer. Let's try this. 7 to the power half times 8 to the power half. If you observe, are the bases same? No. But are the powers same? Yes. And these two terms are multiplied. So what law are you going to apply? What law of indices? Remember this, a to the power m times b to the power m is what? A times b, the whole thing to the power m. Can we apply this law over here? Yes. So can I write this as 7 times 8, the whole thing to the power half, Now 7 times 8 is how much? 56. So 56 to the power half. This is the simplification of 7 to the power half times 8 to the power half. Great going. Let's try to find the value of 64 to the power half using the laws of indices. What can you think about 64? What is 64? Is it a perfect square? It is. Remember, 8 times 8 is how much? 64. So can I write 64 as 8 squared? I can. So 64 can be written as 8 squared. And the whole thing is to the power half. Now which law comes to your mind? Which law of indices? A to the power m, the whole thing to the power n is what? A to the power m times n. So can I apply the law over here? 8 to the power 2 times half. 2 and 2 cancels. So we are left with 8 to the power 1, which is simply 8. So this is all about the law of indices for your grade level so far. So thank you for watching this lesson, and I hope you have understood it. So this lesson was explained by me, Askar Khan, your math coach on Wisdom Outlined. You have my telephone number displayed on the screen. You can contact me if you need math help or math tuition classes. Thank you very much, and do subscribe to this channel and share this video with one and all. Thank you.